How can there be auroras on Mars? More bad news for the exploration of Europa. Watching Pluto's atmosphere change in real time. And in Space Bites Plus, could planets form right after the Big Bang? All this and more in this week's Space Bites. There are a lot of spacecraft that are operating right now here in the solar system, and there are a lot of spacecraft that are long gone. And yet, scientists are still looking through all of the archive data that those spacecraft gathered and making new discoveries about the cosmos. Well, here's another. This is about NASA's MAVEN spacecraft, the Mars Atmospheric Volatile Evolution. And MAVEN was studying Mars for 10 years and was mostly looking at how the atmosphere of Mars interacts with the solar wind. We know that Mars is bone dry today, that it once had water in the past, that the interaction with the solar wind has driven out the hydrogen, the water in the atmosphere of Mars and made it a lot colder and drier. Although maybe the water went underground, we're still not sure. But in December 2025, MAVEN went offline and NASA tried to bring it back and they were unable to do that. And so RIP MAVEN. But researchers have been continuing to look through all the data sent back by MAVEN. And one question that they've been trying to figure out is, how can there be auroras on Mars? Now, Earth has a dynamo at the center of the planet. We have rotating metal. This creates this planet-wide magnetosphere that then interacts with the solar wind. You have particles coming from the sun. They're deflected towards the poles of the planet. And so this is why we see auroras. We're seeing these particles as they're smashing into the atmospheric particles, and you get these beautiful different colored glows, like green caused by ionized oxygen. But in the last couple of years, researchers have discovered that Mars has auroras too. But how? Mars does not have an internal dynamo. If it did have one, it stopped a long time ago. But Mars does have regions of magnetized rock, lava fields that were once magnetized by the global magnetosphere on Mars, but then the magnetosphere went away, but the rocks are still there. And so you get this localized auroras on Mars through the interaction of these chunks of magnetic rock interacting with the solar wind particles. And so researchers looked through MAVEN data and they were able to figure out the exact mechanism for how this is happening. And it's actually very similar to what we have on Earth. Back in the 1960s, a researcher named James Dungy worked out this mechanism for how the Earth's magnetosphere directs these particles into the atmosphere. Now, thanks to the MAVEN data, planetary scientists have figured out that Mars is doing the same thing, that this localized magnetic field is acting like the magnetosphere, but at a small level, and directing the particles into the atmosphere. We've got a story about this from Matt Williams on Universe Today. And then we've got another story by Matt Williams. This time it's about Europa. And I can't get enough of Europa. You've got this world that is one of the giant moons of Jupiter. And we know that because it has these tidal interactions with Jupiter and the rest of the Jovian moons, it likely has an ocean of liquid water underneath a thick layer of ice. The surface of Europa is just too smooth. It should have been hit by a bunch of comets and asteroids, so something is resurfacing its feature, and it's thought this is upwelling water coming to the surface of Europa and then freezing again. And that means that there could be water that is making its way all the way from the ocean through tens of kilometers of ice to the surface of Europa. And so if you can find one of these cracks in Europa, go down into it and then sample that water, then you might be able to actually be sampling the water in the ocean. Well, a new paper suggests maybe not, that unfortunately, water from inside Europa is probably not making its way all the way out to the surface of the moon. Now, there are definitely going to be cracks that are going to form in the ice shell, and water is going to try to seep from the ocean upwards and melting as it goes because it's going to be a lot warmer than the ice. The problem is as it gets into the ice, it starts to cool down and ice crystals form and they clog up these pipes that are trying to deliver warmer water higher up. And so if they do find these pockets of water under the ice on Europa, they're probably still disconnected from the ocean underneath. And so you can't sample the pockets of ice and find out about the ocean. This is all still a moving target. NASA's Europa Clipper mission is going to Europa, and one of its main jobs is to map out the subsurface of Europa. It's going to be able to use its ground penetrating radar system to get down through a lot of the ice and to map out chambers and see how they're connected and see how things are flowing in Europa. And so maybe we'll get a great answer for that, or maybe this will confirm that the water under the ice on Europa is disconnected from the ocean. Now, like I said, I'm obsessed by Europa, and so I've done a ton of interviews on this. Recently, bad news, but I've got a great interview with one of my favorites, Paul Byrne, about how the subsurface volcanic activity on Europa can't provide enough energy to support life in the oceans. And on a recent episode of Space Bites, we reported there might not be geysers on Europa. So more bad news for Europa, but still worth studying. I don't want to make you feel old, but it's been over a decade since NASA's New Horizons spacecraft flew past Pluto. Is it a planet? Is it a dwarf planet? Anyway, it's Pluto, and it's awesome. And as it flew past, it then went into the shadow of Pluto and then looked back and watched as the sun illuminated around Pluto. And you can see this thin, hazy atmosphere around the world. Pluto has an atmosphere. Now, it's not very much of an atmosphere. It's about 1/100,000th the density of the Earth's atmosphere at the surface. But it is still an atmosphere. It's right there in the picture. But Pluto's atmosphere is kind of weird. As it gets closer and farther from the sun, the atmosphere will freeze out and snow down onto the surface, forming a layer. And then as it gets closer and warms up, this snow of an atmosphere will sublimate and puff out into a full atmosphere again. And it goes through this cycle as it orbits around the sun. And the timing for New Horizons was perfect, that it's in the middle of this phase transition between having this thicker atmosphere and that atmosphere cooling down and starting to snow out. Well, now, several years later, astronomers have been watching the atmosphere of Pluto. How do they do that? They're using a technique called a stellar occultation. You essentially watch as Pluto passes in front of a star. And if you watch that occultation from different perspectives, you watch as the starlight dims a little bit as the atmosphere is moving in front of the star, and then Pluto passes in front of the star, and then you see a little bit more of the atmosphere, and then space again. And from different perspectives, you can actually see different changes in density in the atmosphere. So if like one observer is in the US and another observer is in Europe, they're going to see slightly different views of Pluto while this occultation is happening. And from this, astronomers were able to work out that the atmosphere of Pluto is decreasing in density. So between 2021 and 2023, essentially two occultation events, astronomers calculated that it is decreasing density by 16%. So we are watching the decline of Pluto's atmosphere as it's now moving into this, winter is coming on Pluto. It wasn't already winter enough. Got a great story about this from Carolyn Collins Peterson. Gravitational lenses are extremely important because they provide a natural telescope lens that astronomers can use. You can take just the power of your telescope and then use the gravitational lens as like another magnifier, and you can get dozens, hundreds, sometimes thousands of times as much magnification as what you would get just with the telescope alone. These things are gold, and so astronomers are always looking for more of them. And one specific kind is where a gravitational lens has a quasar, because now you've also got this additional form of light coming out of the galaxy that is acting as the gravitational lens. There were only 7 known quasar lenses, and astronomers wanted to find more. So they came up with a really cool machine learning algorithm to be able to do this. They took a look through the back catalog of the Dark Energy Spectroscopic Instrument, or DESI, and this has 800,000 quasars in it. And they have the spectra from all of those different quasars. And then they came up with a machine learning algorithm to find more quasar gravitational lenses. But the problem is you only have 7, so you can't really train on 7 gravitational lenses. So instead, they came up with mock gravitational lenses and put them into the data catalog and then trained the system on identifying these mock lenses that look very similar to the real ones. once they had trained this, they asked it to look through the 800,000 quasars to find all the potential lenses. It found 200, and then humans reviewed those 200 and narrowed them down to 7. And so now they doubled the number of quasar gravitational lenses that astronomers know of, and they can use this for a lot more science. Got a story about this from Mark Thompson. And speaking of machine learning algorithms, another really important use of this is scheduling telescope time. So right now, when you schedule telescope time, you have to take in a million factors. You've got the research itself, like how important and valuable is this research? Is it something you can do anytime, or is it something that is time sensitive? You've got the sky conditions. Are you looking down near the horizon? Are you looking up towards the zenith? Are there clouds? How is the atmosphere right now? Is the moon up? Where's the moon? And so you have to take all of these different factors and then consider what should you be pointing the telescope at any moment to moment over the course of the evening. It is a very difficult skill and takes some of the best astronomers to be able to do this. And so researchers came up with this machine learning algorithm. And what they did was they said, okay, we're going to look at what the telescope is pointing at, and then we want you to predict what the telescope pointed at next. In other words, what did a human say? Well, looking at all the conditions that I have in front of me, what is the next good target for the telescope to point at? And then they trained it on these guesses and then compared it to what the human actually decided was the right target for the telescope next. And then after all this training, they now have an algorithm that is able to watch the telescope, and then after it completes a series of observations, make a suggestion on what is the next in the queue that it should be looking at as the conditions in the sky are changing. It's pretty good. It's not as good as the best people who are choosing telescope time, but this was like their first iteration of this. And the hope is they'll get to this place where it's kind of superhuman in its ability to target this telescope night after night in real time to get more science out of the sky. And this is another story by Mark Thompson. Every week we do a vote on our channel where you tell us what you thought was the best story of the week. And the winner last week was Venus Isn't Dead After All. So thank you everyone who voted last week. Now, once again, we will put this week's poll into the post tab here on our YouTube channel. So go in there, vote for the story that you like the best, and then we will celebrate the results. One update, last week, I asked for your help in hitting 5,000 likes on that video, and you did it. Now, I don't know if that had any impact on the algorithm, so I think we need to do a longer study, more variables. Let's see if we can hit 6,000 this week. Maybe that's the magic number that will finally let the algorithm smile upon us. Or shun us. Who can say? We'll have to find out. News from China. This week, a Chinese Long March 7A rocket exploded about a minute after taking off. We don't know what the payload was, some kind of military communication satellite or something. And the timing is that it was still on the first stage that probably caused the explosion, around the time of max dynamic pressure. You always hear this max dynamic pressure point for all rocket launches, because that's sort of like the scariest time when you've got the most forces on the rocket simultaneously. The rocket was using the YF-100 as its main stage engine. And this is a rocket engine that is used across its fleet, and a lot of missions depend on it, including upcoming lunar missions. So hopefully we'll find out what happened, what the fix was, and that everything is going to be fine. Of course, like expecting to get this kind of news out of China, I think this might be tricky to hear any updates. So at some point, I'll just report on another Chinese rocket launching, and I guess it's all fine. The world space agencies are targeting the moon, and if everyone's ambitions work out, we should see some kind of human presence on the moon in the coming decades. But the moon is very far away, and it is at the top of this gigantic gravitational well that you have to climb out of. And so you want to minimize the amount of material that you bring to Earth. You want to live off the land, try to gather as many resources as you can locally. For example, water. And we know that there are large deposits of water ice at the south pole of the moon, but there appear to be water ice mixed in with the regolith in other places as well. So is there a way that we could find these deposits of water ice? The problem is that these deposits are covered with regolith. And so if you just take a picture of a region, you're not going to see if there's a giant frozen lake of water right there under the surface. But researchers are proposing a really clever trick, which is that you can use seismic waves to find where the water deposits are. And this is a kind of technique that is done on Earth that uses to find oil. But when seismic waves, from earthquakes, pass through water ice, they go 2 to 3 times faster than when they go through rock or sand. And so the researchers are proposing that you set up a seismometer on the moon and then you listen for moonquakes, which we know happen. And then you would be able to detect how the seismic waves are moving through different kinds of material under the surface and maybe triangulate pockets of water ice that you could actually harvest and research. Researchers have demonstrated that this works here on Earth. They took a bunch of simulated regolith, crushed it up, mixed in water ice, froze it, and then watched how seismic waves propagate through these samples. But we don't know if it's really going to work on the moon yet, but it works in principle on Earth. So we'll find out. I've got a story about this from Carolyn Collins-Peterson. And now another update on the attempt to rescue NASA's Swift satellite with the Link satellite. Link is this satellite produced by a company called Catalyst, and they were attempting to launch to dock with NASA's Swift satellite and raise its orbit so that it can continue more years of X-ray observations, helping to study gamma ray bursts and other energetic events in the cosmos. And its orbit has just been steadily declining, and now it's just a few years away from burning up in the Earth's atmosphere. And so the Link satellite was supposed to go and dock and raise its altitude. The problem is, shortly after launch, it started to spin wildly. It lost 2 of its reaction wheels that are used to orient itself. But engineers at Catalyst have been able to slow down the rotation of the satellite. This has allowed them to communicate better with the satellite and upload new instructions, essentially a new way for the spacecraft to orient itself using its thrusters instead of trying to rely on its reaction wheels. So if this software provides the fix, then they should be able to get the rotation stabilized, should be able to catch up with Swift, and then whatever fuel they have left in the tank will allow them to raise the orbit of the Swift satellite. At the same time, NASA engineers have been reorienting the Swift satellite itself to minimize its drag on the atmosphere. So it's still doing science, but it's not lowering its altitude as much. And so hopefully that combination of being able to make Link work as well as make Swift last longer will give this operation a chance of success. Every week I talk about how we don't like to have any ads and how you can watch a version of this episode over on Patreon. But in fact, our campaign against ads runs across everything that we do. So I do a newsletter. We don't put any ads in the newsletter. We do a podcast. There are no ads, no sponsorships in the podcast. And the website is the big one. We have a website that gets almost 20 million visitors a month, and there's no ads on it at all. And that's all thanks to the patrons. And so if you want to watch the version of this video with no ads, because of the patrons, you can watch that over on Patreon. It's completely for free. There's no ads. You don't have to sign up. Maybe give a shout out to the patrons when you watch it. And if you watch this episode over on Patreon, you'll get a bonus story. And this week's bonus story is how conditions might be that you could have planets early on in the universe, maybe within 100 million years after the Big Bang. I'll put a link down in the show notes. We've got a lot of stories in this week's episode of Space Spice, but this is just a fraction of all of the stories that we are covering on Universe Today. And this is the website that I am the publisher of. And we often have 30 to 50 stories a week on Universe Today, and we only have time to cover 8 to 10 here on Space Bites. But if you want to get the full list, and you don't want to just keep refreshing the Universe Today website, you can sign up for my weekly email newsletter. It's completely for free. I write every word in the newsletter. Sign up, go to university.com/newsletter. I'm going to talk about the Perseids and the solar eclipse, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodu, Caradon, Chuck Hawkins, Commander Balak, Dark Finger, David Gilton, and David Matz, and Thaler Reading Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Smith, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Found the Money, Team 49, Tales of Canada, Vlad Chiplin, Wolfgang Klotz, and Zelda Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. For the last few months, I have been reminding you about the Perseids meteor shower, that we were going to have a really good version of the Perseids meteor, which is a mediocre meteor shower. Normally, you get sort of 40 to 70 meteors an hour, but this month it was during a new moon, and so there was no moon in the sky at all for the entire night. And so this is like the best possible Perseids meteor shower that you could get. And the timing on this is really interesting because Europe had this total solar eclipse on August the 12th, the same day as the Perseids meteor shower was peaking. And of course, when you get a total solar eclipse, you're getting the very absolute definition of a new moon, because the moon is passing directly in front of the sun from our perspective. I wasn't able to see the total solar eclipse this year. I got some invites, and still sort of the amount of travel that would have been required to get into this very thin strip to be able to watch it meant I wasn't able to do it. But I would love to hear your experiences. Did you watch the Perseids? Did you follow my advice and watch the Perseids? I laid out under the stars with my wife, and we watched for a couple of hours. I think we counted up about 8 Perseids, but there's still a lot of glow in the sky, and so we weren't able to see like the truly good dark Perseids. Got a couple of pretty great long streaks that went all the way across the sky. So I followed my own advice. I went out and watched the Perseids for a couple of hours. But tell me, how was your experience? Did you watch the Perseids? Did you see the total solar eclipse? Are you now one of us? Now you want to see as many solar eclipses as you possibly can? Let me know your experience in the comments down below, and I will keep reminding you of really cool sky events that are coming up. All right, we'll see you next time.